we'll continue talking about verifying trigonometric identities. Example 4 says to verify by factor. So you'll see in this one that I have, if I'm looking at the left side, I have a cotangent and a secant. I have more than one cotangent and a secant from both things. So what I'm going to do is I'm going to factor those out. So I get cotangent theta, secant theta. And if I take those out of it, I have cosecant squared theta minus, I took one of the cotangents out, so I still have two of them left, is equal to cosecant theta. Now, if you look back at our Pythagorean identities, cosecant squared minus cotangent squared is actually just 1. So that goes away. So now I'm left with cotangent theta secant theta is equal to cosecant theta. Now, what I'm going to do is I'm going to change my cotangent and secant into sines and cosines. Well, remember, cotangent is just cosine theta over sine theta times secant is 1 over cosine theta is equal to cosecant. Now, you'll see in this multiplication problem that there's a cosine in the top and one in the bottom. So those actually cancel each other out. And I'm left with 1 over sine theta is equal to cosecant theta. And you'll remember from your trig identities, your inverse trig identities, that 1 over sine theta is actually just cosecant theta. So we have cosecant theta is equal to cosecant theta. So they're equal. So we can box it. Here's a guided practice problem. You can try the same. Try by factoring something out of both the left and right of an addition or subtraction problem. Now in this one, it's going to be a little bit trickier. Now the hard thing is that both of them look pretty difficult to solve. So what I'm going to do is I'm going to look at each one independently and see if we can get them both into equal something the same in the end. So for the left side first, I'm going to look at that side. Well, let's write tangent squared as a different thing using secant. Well, if I want to rewrite that, remember tangent squared is the same as secant squared of x minus 1 all over 1 plus secant of x. Alright, so now what I can do is I can kind of break those up a little bit. I'm going to take secant squared of x and I'm going to say, okay, well I've done it enough now that I know that two conjugates always multiply to secant squared minus 1. It's a difference of squares. So that's the same as secant of x plus 1, secant of x minus 1, all over 1 plus secant of x. Now, it might look a little bit different. These two are very similar. Now remember, addition is commutative, so it doesn't matter which way it's going. So I can actually rewrite it. Instead of 1 plus secant, I'll try to do secant plus 1. And now check it out. These two are the exact same. Now I can't do that with subtraction, but I can do it with addition. And so I cancel those out. And so the left side is actually just equal to secant of x minus 1. Alright? So what I can do now is I can look at the right side. I can look at the right side. And so that was 1 minus cosine of x over cosine of x. Now I'm stuck. I'm not entirely sure what I want to do with this. So I said whenever I'm stuck and there's a fraction, what I can always do is just rewrite it as two different fractions. So that would be 1 minus cosine of x, or 1 over cosine of x, 1 over cosine, minus cosine of x over cosine of x. Well, cosine of x over cosine of x, that's the same thing, that's just 1. So this is just 1. And 1 over cosine is actually just secant. So now I have secant of x minus 1. And so the thing you'll notice is that I had secant of x minus 1 on the left and secant of x minus 1 on the right. So are those equal to each other? They are. So you can just write secant x minus 1 is equal to secant x minus 1. I box it because I've got both sides equal to the same thing. And I am done. Here's a guided practice problem. Same sort of idea. Both look a little bit different. Start by trying to get both the left and right to be the exact same. Alright, so here's some strategies for verifying. Start with the more complicated side of an identity and work to transform it into the simpler side. Always the easiest one. Use reciprocals, quotients, Pythagorean, and other trigonometric identities. That's a big one. That's the one I tell you about changing it to sines and cosines. It's always way easier to do that. Use algebraic operations such as combining fractions, rewriting fractions as sums or differences, multiplying. So that's what I said. When you're stuck, it's always easier to rewrite as an addition or subtraction problem. Convert to the denominator to the form of 1 plus u or u plus 1 in a single term by its conjugate. Okay, so we like to use conjugates in that. Work on each side separately. That's the last one we just did. Okay? Alright, the last thing we can do is to use a graphing calculator to test whether each equation is an identity. If not, if it appears to be an identity, verify it. If not, find a value for which both sides are defined but not equal. So let's first look at A. Okay, cosine of beta plus 1 divided by tangent squared of beta is equal to cosine of beta divided by secant of beta plus 1. Well, to look at that, I'm going to go right to my Desmos app. And if I look at Desmos right here, I've already typed it in, you'll see that I have two lines. The red line is the left side of my equation, and the blue line is the right. Now, do they mirror each other? Are they the exact same? Do they copy each other? The answer is no. So these are not an identity. So if you go back to this, you would just say not an identity. And if it's not an identity, you can't solve it. There's nothing you can do. You can't go in and try and do anything because it's not going to work. Okay? Not an identity. So let's look at letter B then. Cosine of beta plus 1 divided by tangent squared of beta is equal to cosine of beta divided by secant of beta minus 1 instead of plus 1. So I'll go back to decimal. Now in this one you'll see it looks like I have one line. I only have blue. But then if I go up here to red, well now it turned to red. So you'll see they're right on top of each other. So if they're right on top of each other, it means that these two do form an identity. And so we'll go back to the problem and we'll prove that identity now. Now I'm going to start with the right side. The reason I'm going to start with the right side is because I know I can take tangent, or secant minus 1, multiply it by its conjugate, and then it's going to give me tangent. I can substitute that in. So that's what I'm going to do. So I multiply top and bottom of secant beta plus 1. Okay, I'm just looking at the right side now. Okay, so I get cosine beta secant beta plus cosine beta all over, and then secant beta is going to be secant beta squared. And then minus 1 plus 1 would be minus 1. Remember, since it's the conjugate, the backside drops off. Okay? Well, if you remember, secant is actually 1 over cosine of beta plus cosine of beta all over secant squared of beta minus 1. Now I told you already, okay, that this actually turns into tangent squared of beta, and cosine beta times 1 over cosine beta, those cancel each other out, so that's just 1, right? So this actually turns back into cosine beta plus 1 all over tangent squared of beta. Now you'll notice that this was 1 plus cosine. I flipped it around. Remember, commutative property works for addition. So you'll notice that this side right here, the left, is now equal to the right. And so since they're equal to each other, this is an identity. We box it, and we are done.